Go ahead.
Okay. All right, great. Good afternoon, everybody. My name is Cindy Dominguez, and I'm at the MITRE Corporation. There's quite a nice center of gravity growing of NDM folks at MITRE, which I'm really excited about. But when I did this work here, I was a part of the old Klein Associates Division of Applied Research Associates, and several of the team members that are here participated in that work, including Brian Moon and Lisa Popowski, who's here, and Robert Strauss, whom I don't believe is here. And so what's unique and interesting about this? The title was Autonomous Flight Application, but as Robert Hoffman mentioned earlier, aircraft are never autonomous, systems are never autonomous, and the focus of this work really was on this Marine in the field who's holding a little tablet, and their mission of receiving unmanned helicopters, delivering them all of the necessary supplies that they need to do their mission and survive. What was really unique about this project, which is part of the ACUS, Autonomous Aerial Cargo Utility System project, was that there was a really total team integration effort across the engineering team that Aurora Flight Sciences led. And there was a lot of design that was involved. We brought on the design expertise of Robert Strauss, which was really cool. And so you'll see some of that, how we work that into it as I go along. So I've been a part of NDM for about 30 years now, and I'm really, really excited to see this get off the ground. The context here was that ACUS was an innovative prototype from the Office of Naval Research. And if you look at the picture here, you'll see this device in the nose. It's portable autonomy meant to be attached to any different kind, any helicopter that could accommodate it in order to adapt that helicopter to a mode of operating in an autonomous way, if you will. But what is the trail? What does it mean for the mission that your delivery helicopter is quote unquote autonomous? There are a lot of implications here. And so we were brought on to this Aurora Flight Sciences team with cognitive engineering and cognitive task analysis work in this team of teams to try to understand that and suss that out. And I will just give credit to the program manager, Missy Cummings at the Office of Naval Research, who I think was pretty insightful and forward-thinking to incorporate this effort into that ONR program. So the challenge here, I'm really talking about this first one in this talk today, since there's little time and it's a lightning round. The idea of creating a simple, intuitive, handheld interface for an untrained Marine at the enlisted level of 4 at a combat outpost. And so clearly Marines are trained in a lot of different things, but they're not trained on taking a mini iPad and using it to vector in an unmanned helicopter. And so we had this criteria that we developed in our team, which was that the interface had to be so simple that the Marine could learn to use it in under 15 minutes. So that was a high challenge. We had to make this very intuitive. We later worked on some other software for the main UAS pilot back at the main base and some other efforts, but I'm going to focus on that. And I will say that this presents an envisioned world problem. Those of you who've been in this field understand when you're not just modernizing an existing system, but you're creating something entirely new, it presents a whole new set of problems. And if you're new to the field, there are some great papers out there by Dave Woods and others on this envisioned world problem. So here's a simple approach, really, and I continue to use this to this day, which is just gather data to understand what's going on, analyze those data, design and evaluate, wash, rinse, repeat. And so that's really what we're going to do and what we did and what I'm going to talk about here. In that understand or gather phase, you can see that we conducted these interviews with various subject matter experts, but what was key was to understand what's really important and difficult about helicopter pilots landing in a field which has not been graded for them. What are the things that can go wrong? Turns out there's a lot of things that can go wrong when you try to land a helicopter in an area near a combat outpost that's recently been cleared. What's important and difficult about, from the ground perspective, on securing landing zones, designating them, setting them up, and watching and receiving resupply from a helicopter. So we learned about a lot of that in our interviews as well. And then in terms of the things that we learned from unmanned aircraft systems, pilots, and main operating base experience, the aspects of planning and coordinating these unmanned aerial systems missions in a challenging environment, which included a lot of threats. So we really tried to triangulate by understanding what's difficult from all these areas to gain this envisioned world understanding. We used a range of methods that you can see listed here, which you may or may not be familiar with, but there's a lot of information about them out there. And in the interviews that we did, we were really fortunate to have this multidisciplinary team of the software engineers and the engineers of the perception systems and the autonomy and the program, which were really helpful. We had a number of artifacts. I think sometimes analysis in that aspect of how do you analyze the data is underrepresented. We did some unique things here that were of direct benefit to the engineering team. One was this use case architecture, breaking up the trip for each mission into sort of the en route phase, the approach phase, which is really challenging coming into the combat outpost, the landing aspect, and then the extraction that we worked on. We developed a set of requirements. Here's an example one here in number 2. We created a state flow / mission model for the engineering team to use to understand what this flow looks like and what's important there. And then I'm going to spend some time here on the storyboard designs, because those were really cool and fun. And I think they really set our team apart on this effort. And I'll talk about that next. So jumping into the design effort, we used a participatory design approach. And our objective was to use the minds and the thinking of many different people on the team to design this combat outpost user interface from end to end. And so if you're familiar with participatory design, you very carefully develop and select your how might we questions, such as how might we support negotiating a landing location with a handheld device. And we went through a very common process of brainstorming, organizing, breaking out into design teams, and then presenting across the team what we came up with in these design teams, and then selection. And so we had a lot of attendees, and this is a picture of the room where it happened there. I will say that following the workshop, we directly put our prototypes into a form factor we knew we were going to use. We came up with a lot of ideas. We were looking at a glyph, a very simple glyph, to help the Marine operator understand what was happening and where the aircraft was with respect to them, because they're not really flying the airplane. They're just responsible for vectoring it in and understanding where it's at. So here's some sort of interim products and ways that we represent it and how a person might interact with it. And then we came up, I think the work of Rob Strauss after our workshop to transform these paper and pencil artifacts into something really cool. He both created storyboards that showed what's the Marine doing and what does that look like and represent that. And this is a field operator confirming permission to land and then actually assuming control of the ACUS enabled system. And that's sort of when they assume control. Now there's a circle that goes around. And then they would tap the camera icon to enter this camera mode and find the aircraft on the horizon. So there's a lot here. I understand it's complex, but we tried to make it as simple as possible to give them options of showing a map space. Where does the chat go if they're chatting back with the main operating base, and so on. We took these initial sort of PowerPoint-like designs and evaluated them with some Air Guard security forces that had a lot of experience deployed in combat outposts. We had a lot of different goals for that evaluation that we looked at, but overall, we got some excellent feedback on our design and how to make it better. And then after the evaluation, we had a final storyboard. We simplified some things. We put the chat in the bottom. We had a very simple, intuitive little listing of parameters that people needed to understand. And we came up with a whole series of these in the form factor. We confirmed that the iPad mini would fit in the pocket of the BDUs that the airmen wear as well. So in summary, we developed and validated these designs for the program using NDM cognitive engineering, cognitive task analysis methods. And these were implemented. Flight tests were highly successful. I left the project and went to a new role right before the phase 2, but I understand from others that the team, or ACUS, ONR, and Aurora Flight Sciences, received a couple of awards that were pretty prestigious for their overall work. We were able to train the Marines in under 15 minutes, and then the Aurora team won the competition to move on to the next phase. So I will just say that if you're interested in more detail on these, there's 2 publications out in the open literature here that you can find from the Journal of Cognitive Engineering and Decision Making and the Journal of Human Robot Interaction. If you wanted to get in touch with me, I'd be happy to send you either one of them. And that's it.